Wrapped in an unyielding blanket of clouds concealing what lies within its heart, rests a world that we have long considered the lost twin of Earth. Astronomers speculated that beneath that veil of storms could lie a place where life might have found a way. Venus from the dark reaches of the solar empire was calling us, enticing us to explore that uncharted terrain. However, we couldn't know what the clouds hid without piercing through them. To find those oceans, rivers, and even the life that many dreamed of, there was only one destination. In the early 1960s, amid the height of the Cold War, the Soviet Union embarked on developing its Venera program, a series of missions to explore the world. Unable to prepare them for conditions they didn't know, many probes failed. But with each failure, with each attempt, we learned more about a landscape that we already knew was akin to hell. Until finally, more than 20 years after the start of that ambition, on March 1st, 1982, the Soviets took a giant leap forward in that space race. The Venera 13 probe began its descent through the clouds that had always deprived us of looking our brother in the eye. Passing through the cloud cover, enduring pressures of 90 Earth atmospheres that could crush a car in seconds, and temperatures high enough to melt lead, the probe ventured into the heart of hell. With it, a part of humanity had settled on the surface of Venus. A countdown marked the time for us to assimilate all possible information about our corrupted twin. The Soviets were taking the first color images of the world's surface, transmitting to our home data that would help us understand its nature. But barely 127 minutes after landing, unable to survive any longer, Venera 13 perished before the wrath of Venus. Forever hidden beneath that veil, it had deciphered the secrets hidden in its atmosphere. The first time we closely witnessed the fury of the winds beyond our home. About 60 kilometers above its surface, the winds reached speeds of nearly 500 kilometers per hour, fiercely whipping the skies and causing the clouds to complete a rotation around the world in just 4 days. Hypervelocity clouds from which acidic rain emanates, turning the planet into the hell of the solar realm. The winds of Venus are so fast that even the fiercest hurricanes on Earth pale in comparison. And there's a reason behind that wrath in the skies. Venus's rotation is very slow. It takes about 243 Earth days to rotate once on its axis. In fact, considering that it completes an orbit around the Sun in 225 Earth days, in a way, a day on Venus is longer than a year. This extremely slow rotation speed, combined with its proximity to the parent star, condemns its climatology. Although temperatures never drop below 400 degrees in any region of the world, this slow rotation means there is one face more exposed to the scorching heat of the sun. A long day and a long night. In the warmest region, the air rises towards the skies. Once there, thermal convection takes care of the rest. Due to differences in air densities, the hot air moves towards cooler regions, towards the night side of Venus. This continuous current is what feeds the furious winds we had encountered on the planet. But we were barely aware of the fury that awaited in our twin skies. On April 11, 2006, as the culmination of the European Space Agency's first mission to the world, Venus Express began orbital insertion maneuvers, navigating around the planet to study its atmosphere and surface in great detail during the 8 years that the mission was to last. In one of its early flybys, the probe's infrared cameras captured something strange at the South Pole, something humans had never observed. Images from Venus Express revealed the existence of a dipolar vortex. A vortex with 2 rotation cores in opposite directions, one in the upper atmosphere and one in the lower. we were seeing a hurricane with two eyes. Our evil twin contemplating a part of us through that unyielding veil of clouds. The vortex was about 3,000 kilometers in diameter, and the two hurricanes rotating around each other seemed to be a permanent feature in the skies that had been silently waiting for us to discover them. With winds reaching speeds of hundreds of kilometers per hour, inside we would see a kind of inverted tornado as the air is channeled from the top to the surface of the planet, all flanked by a wall of clouds. Our brother had shown us his secrets. It was time to continue sailing the oceans of darkness in search of the great hurricanes of the universe. The odyssey of the megastorms had begun. After 166 days of flight through the cold and dark void of space, the Mariner 9 spacecraft reached its destination. Destined to decipher the best-kept secrets of a world that had always fascinated us. On November 13, 1971, the spacecraft became the first probe to orbit another world stably. NASA had arrived at Mars. However, all that Mariner 9 found upon arrival was a veil of darkness. A haze was covering the entirety of the red planet. We had encountered an immense Martian storm, the largest sandstorm ever seen. The world was hidden beneath the fury of its skies. Despite its thin atmosphere, Mars experiences strong winds that whip across a surface covered largely by vast expanses of sand and dust. Vortices can lift these particles, creating updrafts of material that are carried by atmospheric currents. A sandstorm has formed that can reach an altitude of 20 kilometers, and due to the world's geography, has free rein to grow. There is no limit to how far it can spread. There are no oceans where dust and sand find a barrier, nor rain to dissipate the particles. All they find are new expanses with more material to feed the storm. Once the storm has formed, only gravity can slowly return the dust to the ground. A process that can take weeks or even months. More than enough time for the sandstorm to grow to planetary size, burying the entire world in darkness. But this was not the only strange meteorological phenomenon that Mars hid. In January 2004, as part of the Mars Exploration Rover mission, the Opportunity rover landed on the Red Planet to begin an exhaustive study of the Martian surface that would last more than 14 years. Upon its arrival, Opportunity captured extraordinary images. Something was traversing the soils of Mars. The rover's cameras photographed swirls of sand, dubbed dust devils, sucking up the iron oxides that give the world its reddish color. A kind of Martian tornado that could reach over 100 meters in diameter and spin at over 120 kilometers per hour. When sunlight heats the surface, there are areas that heat up more quickly than the surrounding ones, forming masses of hot air that, by convection, move away from the ground, creating the core of the whirlwind. At the same time, temperature differences generate vortices in the atmosphere that spin and collect sand and dust particles, forming a whirlwind whose construction can intensify to the extreme case of Mars. Martian dust devils can reach heights of up to 1 kilometer, carrying dust and sand into the skies of the Red Planet. A world that seemed dead, frozen in time since an ancient era, had shown signs of its fury. But the journey to the great storms of the universe had only just begun. Beyond the asteroid belt lies the king of the solar empire, a mysterious, immense, and intimidating planet that hides its violence beneath a precious canvas painted in its clouds. Jupiter was a monster that had always marveled us. But deciphering its true nature required the most exquisite space technology. It wasn't until July 4th, 2016, that we were ready to read its story when NASA's Juno spacecraft, after 5 years sailing through an ocean of darkness, inserted itself with surgical precision into a polar orbit around Jupiter never before achieved. Very close to the giant, at just 5,000 kilometers above its high clouds, Juno gave us images that perfectly captured the violent beauty of the world. Winds of up to 650 kilometers per hour lifted cold clouds turned into artistic swirls. A mosaic of fierce storms. But it was while navigating its North Pole, a hitherto unexplored location, that Juno found an inexplicable formation in its atmosphere, a perfectly geometric storm, an octagon in which 8 megacyclones spin around a central storm. Winds roar inside the whirlwinds, each of which is larger than the United States. Witnesses to the fierce splendor of its climate, a mystery presented itself before us. It made no sense for Jupiter, receiving so little solar radiation being so far from the parent star, to have such a level of activity. Something had to be fueling its storms, and the sun couldn't be the only culprit. However, when Juno discovered that the lower regions of the storms were hotter than the upper ones, we began to shed light on that enigma. It was the giant's bowels that were nourishing its fury. Gravity from its core hid the origin of Jupiter's megastorms. The world has so much mass, so much material accumulated in its bowels, that fierce gravity makes its interior a tremendously dense and hot place, with a core probably at temperatures much higher than those on the surface of the Sun. Juno's data suggest that dense material rests at its core, too massive to be only hydrogen and helium. Everything seems to indicate that what awaits in its bowels is rock at extremely high pressures and temperatures, a legacy of the giant's formation in the dawn of the solar system. A reminder of an era of creation imprinted on a heart that today, more than 4 billion years later, is still trying to cool down. Jupiter's core burns at about 24,000 degrees, still shedding heat from its formation, heating the gas layers above it and creating turbulent columns that form the fierce storms on its surface. A climate fueled by the heat and gravity of its bowels. However, even with that furnace in the depths, the temperatures measured in the upper atmosphere remain too high. At least for a world in the cold reaches of the solar system. Luckily, one place on that giant hid the last piece of that colossal puzzle. Infrared readings of the Great Red Spot, Jupiter's largest anticyclonic vortex, show that the largest storm in the solar system is being heated by an unknown process. Something in that monster with winds of 600 kilometers per hour that shape a storm whose diameter could fit the Earth, and that rises 8 kilometers above the clouds was generating heat. And there was only one thing that gave us the answers to its origin: the deafening sound of the storms it hides. The titanic thunder that emerges in the turbulent depths of the Great Red Spot creates sound waves that behave like pressure waves. The sound compresses the gas molecules in the atmosphere. It is physically converting into thermal energy. At the same time, at the boundaries of the storm, where the winds are faster, collisions with the rest of Jupiter's atmosphere are generated. New sound waves are being created that accumulate more and more energy, to the point of escaping their jaws, reaching the upper atmosphere, and once there, unable to maintain their stability, releasing all their potential in the form of heat. Although the most powerful, the Great Red Spot could not explain all the planet's heating, adding the role of all the other small storms that inhabit its clouds. There, suddenly, everything fit. a combined effect that is spreading thermal energy throughout the gas giant, helping to keep warm a world that should live in eternal cold. With Jupiter, we had understood the true power of megastorms, monsters capable of deciding the fate of the worlds that witness their birth and demise. But in that journey through the cosmos, we still had to discover the true giants. And all roads led to one place, to the Lord of the Rings. Bathed in a light 100 times fainter than Jupiter's, we expected Saturn to be a gentle giant. However, on Christmas Day of 2004, after a 7-year journey through the solar system, the Cassini probe reached its destination, and we understood the true nature of the ringed world. One of the greatest feats in the history of space engineering had entered orbit around Saturn. Developed in collaboration between NASA and the European Space Agency, Cassini had been conceived to reveal the secrets of the gas giant and its moons. During one of its flybys, while navigating the planet's north pole, Cassini sent back a breathtaking image of what was coursing through its skies. A hexagonal storm of intense blue. A sight we had never seen on any other planet in the solar system. But although the existence of such an entity seemed impossible, nature alone was capable of creating something so perfect. Unlike Earth, gas giants do not have a solid surface. They are colossal rotating spheres composed entirely of gas and liquid, under extremely high pressures. Simulations and experiments in controlled conditions show that on these worlds, where the poles rotate at much slower speeds than the rest of the planet, geometries at these poles emerge naturally. In those places where the fast fluids from the exterior meet the slow ones in the center, formations as incredible as Saturn's hexagon can arise. They are an inevitable consequence of the planet's rotation. After a long time observing the world of the rings and its moons, on December 5, 2010, Cassini witnessed one of the strangest phenomena in the solar system. Approximately every 30 years, the mother of all storms is born in Saturn's atmosphere. The largest and most powerful storm in the solar empire, which we name the Great White Spot, erupts as if from a volcano. And although the next one was expected in the decade of the 2020, with the probe having perished years earlier, fortunately it came earlier. Cassini was in the right place at the right time to witness its wrath, and above all, give us information about what was fueling the colossal storm with winds of 600 kilometers per hour. Its radio detector picked up a crackling from within. The sound of thunder booming in the depths of the Great White Spot. The sheer force is astonishing beyond our imagination. Cassini is telling us that every second 10 lightning bolts emerge in its heart. Each one 10,000 times more powerful than any lightning on our world, illuminating the skies. Like a god, the storm is tormenting the bowels of the giant, and a wonderful process is unleashed. The lightning breaks down the methane molecules in the air, giving rise to solid carbon, a soot that creates dark clouds. Graphite has been generated that inevitably precipitates to where all paths end. But on that journey, when the graphite reaches a depth of 7,000 kilometers, something changes. At that point, with a pressure of 15,000 atmospheres and temperatures of 2,000 degrees, the graphite turns into diamond. The storms have made it so that in Saturn's depths, there is an eternal rain of diamonds that sprinkle the corrupted heart of the giant. But even diamonds perish before its power. At a depth of 40,000 kilometers, where Saturn's energy source is finally revealed, pressures are so intense that gases begin to behave like liquid metal. A heart of molten helium that releases an enormous amount of energy in the form of heat, which due to the world's own composition, accumulates until it reaches a point of no return. Back on Saturn's surface, we can see how the parent star generates a veil that turns the atmosphere into a pressure cooker. Sunlight breaks gas molecules. Hydrogen, helium, methane, and ammonia decompose to rebuild as solid particles, creating a kind of haze in the atmosphere. The tiny dust particles absorb and scatter most of the light radiation, making it difficult to observe the depths of the world through visible light. The haze had erroneously led us to believe that Saturn was a peaceful world. Cassini's infrared cameras show us how indeed we were blind. Saturn is a world tormented by fierce winds, storms hidden behind the haze. The ringed world under that veil of dust is roaring, gathering strength to erupt. The existence of that haze not only blocks our view of what happens inside Saturn, but also turns its skies into a pressure cooker. The heat from its core heats the entire atmosphere, but because of the dust veil, the gases cannot rise to the surface. Inevitably, thermal energy increases more and more. Storms are born under the haze, accumulating years of fury until suddenly, the pressure exceeds a point of no return. The veil is unable to contain them any longer, and the clouds pierce through hundreds of kilometers of dust. The storm has erupted, releasing 30 years of wrath in a single violent explosion. The great white spot that Cassini, by a fortunate twist of fate, had observed, has just formed. Saturn's megastorm remained in the skies for 6 months, a time during which it grew to completely encircle the world, covering an area of 4 billion square kilometers. All of its wrath transformed into that whitish storm that slowly faded away, dormant in its depths until the heart of the Lord of the Rings awakens once again. Beyond the realm of the gas giants lies the icy domain of the outer solar system, the home of the furthest offspring of the Sun. Neptune is the 8th and final planet of the solar system, an icy giant 17 times more massive than Earth that we visited for the first and last time over 30 years ago. 12 years after its launch, the Voyager 2 probe made the historic flyby of Neptune on August 25, 1989, becoming the only spacecraft to navigate the empire of this distant planet, a world far from the light and heat of the parent star. Before the arrival of the probe, given its extremely cold environment, we believed we would not find any relevant climatology. Temperatures on Neptune never exceed -220 degrees Celsius, as it rests 4.5 billion kilometers from the Sun, 30 times the distance between us and the parent star. A world that should be frozen in time. There should be no energy to sustain it. But the images sent by Voyager 2 during its flyby shook the astronomical community. To the perplexity of everyone, the probe's photographs revealed the existence of a gigantic storm roaring in the Neptunian skies. The winds were fiercely moving through the atmosphere at speeds that seemed to reach 2,000 kilometers per hour. Neptune, as the data revealed, was home to the fastest winds in the entire solar system. Winds that were breaking the sound barrier. A planet that should be in a near-death state was overflowing with activity in its clouds. Neptune was alive, roaring with the fury of the winds. Something had to be fueling it, and the Sun at such a distance could not be the answer. In fact, Voyager itself discovered that Neptune was emitting into space 2.5 times more heat than it received from the Sun. The only explanation, therefore, is that its depths were very hot. Perhaps due to radioactive materials in its core, or from the residual heat of its formation, slowly emanating through a still-warming atmosphere. If we were to descend into the abyss of Neptune, we would see that the atmosphere becomes denser and denser, like a thick fog, until finally, we wouldn't even be immersed in a gas anymore. We would find ourselves in an ocean trapped within its bowels. Neptune's mantle is a super-dense fluid consisting of water, ammonia, and methane. A state of matter that retains heat, like a mantle, isolating the planet's core. This should be the origin of the giant's devastating climate. But something in this theory was failing. Not even this residual heat was enough to explain the existence of winds breaking the sound barrier on its surface. Suddenly and unexpectedly, Neptune's climatology had become one of the great mysteries of space exploration. Only one hypothesis seemed to fit all the pieces. And it was that the interior of Neptune is home to a strange cosmic alchemy. In the abyss of Neptune, pressures reach levels up to 8 million times Earth's. In that place, in an environment of pure hydrogen and carbon, molecules can crystallize to form, just like in the ring world, a rain of diamonds. The carbon is subjected to so much pressure that the jewels emerge in the giant. And it could be precisely these diamonds that are responsible for the inexplicable extra heat. At about 10,000 kilometers deep, in a muddy ocean of water and carbon, these diamonds the size of a human are spontaneously forming to fall, by gravity, towards the heart of the world. In this descent into the abyss, the colossal diamonds generate friction with the ocean they are sliding through. Friction that during the long journey to the core is generating heat continuously. Combining this with the residual energy from its formation, everything finally fit. If we add to this that there is no solid surface, only exotic liquids in the depths and gases in the high zones, without mountains or continents to break the airflow in the atmosphere, the mystery of Neptune's climate was closed. Fueled by diamonds igniting its bowels and heat from its formation, without being stopped by any land at its feet, the existence of supersonic winds was plausible. During that revealing flyby, Voyager 2 took another image showing that Neptune not only had extremely fast winds, it was also home to colossal storms. The probe photographed a mysterious hurricane coursing through the planet's surface in the opposite direction to the world's rotation, which we dubbed the Great Dark Spot. The storm was about the size of the Earth, but we didn't have time to find its origin, or explain why it had that strange black color. 4 years after the discovery, the Great Dark Spot had vanished. With Neptune, the last chapter of the Wrath of the Winds in the Empire of the Sun was closed. In the cold and dark distances of our home in the universe, we had found the most extreme climate in the solar system. But there was still one last frontier. Hunting those storms beyond our realm. Winds coursing through the skies of worlds under the light of other stars. On October 6, 1995, a team of Swiss astronomers announced the discovery of an extrasolar planet orbiting around 51 Pegasi, a star located 50 light-years from Earth. Object of speculation and controversy since the 16th century, we had confirmed the existence of worlds beyond the Empire of the Sun. Dimidium, as it was named, was the first exoplanet ever discovered. But it wasn't until years later, with technology allowing us to delve into the nature of worlds beyond our horizons, that we understood the ferocity awaiting in its skies. When an exoplanet transits in front of its star, light passes through its atmosphere, and depending on its composition, it will be altered in one way or another. Today, we are capable of capturing that faint light, and by examining the spectrum, we can infer its chemical nature. And from how Dimidium scatters light, there is strong evidence that it is inhabited by clouds that traverse its skies. Clouds in a hell where temperatures reach 2,000 degrees and are deduced to be formed by aluminum oxide, creating a landscape beyond our imagination. Dimidium is the prototype of what we know as hot Jupiters, gas giants orbiting their parent star extremely closely, in contact with hell. Specifically, this hell navigates the vicinity of the god of light at just 7.5 million kilometers, 20 times closer than we are to the sun. And it does so in a very peculiar way. It is tidally locked. One side constantly exposed to the fire of its sun, and the other in permanent darkness of space. A phenomenon that in other worlds we have discovered causes immense temperature differences between both sides. But we do not observe this with Dimidium. Infrared readings showed that despite this tidal locking, temperatures in the eternal day and the eternal night were practically the same. Something must be transferring that heat across the world. We were capturing the signs of one of the greatest megastorms in the universe. Dimidium is receiving 20,000 times more solar radiation than Jupiter, a bombardment of energy that heats its atmosphere, unleashing hell. Gases expand, and due to the colossal differences in density between day and endless night, they desperately seek cold. The winds roar and travel to the hidden face of the world at speeds that can reach 6,000 kilometers per hour. It's not that they break the speed of sound, they're multiplying it by 6. The most colossal storms we had witnessed in the solar system were nothing but a breeze compared to this hell. A world whose skies, battered by Titanic winds, harbor another wonder of cosmic alchemy. In the deep layers of its atmosphere, aluminum oxide could crystallize under the extreme pressures and temperatures, condensing into its crystalline form. Sheltered under an infamous storm, a veil roaring fiercely in its skies, sapphires would rain upon the corrupted heart of hell. At a distance of 63 light-years away, orbiting around an orange dwarf star, lies a world that at first glance may remind us of our home. A blue planet that stands out as a peaceful landscape amidst the darkness. But in its case, looks can be deceiving. HD 189733b is an exoplanet that is also part of the family of hot Jupiters, and once again, is tidally locked to its parent star. And beneath that mosaic of peace, beneath those white clouds floating over a lush blue canvas, it hides a new vision of hell. The temperatures are so high, up to 1,800 degrees, that the very skies are evaporating. The atmosphere is escaping the planet's gravity at a rate of 6 billion kilograms per second. But that's not the only hostility the giant holds. Infrared readings showed that just like in Dimidio, the air currents between the eternal day and night unleash Titanic winds 25 times faster than the fastest hurricane ever recorded on Earth. The results indicated that winds in its depths could reach speeds of 8,700 kilometers per hour, 7 times the speed of sound, making it the world that holds the record for the fastest winds ever measured in the known universe. Simultaneously, the blue hue has provided clues to another threat sweeping through its skies. Silicate grains or droplets of molten glass are more efficient at scattering blue light compared to other wavelengths of the visible spectrum. It is likely that these particles, turned into sharp weapons, navigate the titanic winds of the world. A bombardment of glass shards and silicates cutting through the clouds at 7 times the speed of sound. The most lethal megastorm we have found in our galaxy. A wrath of the gods lurking in what seems to be an oasis in space. On May 8, 2012, one of the great milestones in the history of exoplanet hunting was achieved. For the first time, we detected the light of an extrasolar terrestrial planet. A rocky world with approximately 8 times the mass of Earth orbiting around 55 Cancri, located 41 light-years away in the constellation of Cancer, a binary star system that torments its offspring to the extreme. Janssen was classified as a super-Earth, a planet with a mass similar to that of Neptune but with a solid surface. Observations showed that incredibly it completed 1 orbit around its suns in just 18 Earth hours. It had to be very close to its parent stars, and therefore have extremely high temperatures. Being tidally locked, temperatures on its daylight side should be high enough, around 2,500 degrees, to melt rock, turning Janssen into a world of lava. Eternal oceans of magma flowing across its surface, with lava so hot that it would behave like water. Seas of fire feeding the jaws of hell. On the side of eternal night, the landscape would be very different. Trapped in eternal darkness, that hemisphere would be a desolate and cold place. A world of fire and ice in the depths of the galaxy where winds could roar, creating a chilling spectacle. In the endless day, gases from the ocean of lava rise into the skies to be condensed in the atmosphere. Clouds formed of liquid lava have been created. Silicates have transformed into bright clouds that reflect the lava at their feet and hold toxic gases. Just like on the gas giants we had visited, differences in densities between day and night are responsible for transporting these clouds. Winds carry these lethal clouds to the dark side of the world, unleashing all the fury of hell. At these lower temperatures, the lava precipitates to the surface. A rain of molten rock on a world tormented by the light of 2 suns. With it, the journey through the worlds that harbor the wrath of the winds had ended. But there was still one last chapter in this story. To explore the last great storm in the universe. The one that emerges in the skies of a failed star. The stars are born when immense clouds of gas and dust collapse under their own gravity. When the pressures and temperatures in their cores reach a point of no return and nuclear fusion reactions begin. But there are occasions when they fall short of this inferno. If there isn't enough mass in the cloud, if the gas is unable to collapse with enough fury to ignite the fiery depths, everything comes to a halt, frozen in a failed star, a celestial body that wanders like the memory of its attempt to become a god. We have forged an entity that we call a brown dwarf. Too large to be a gas giant, too small to be a star, a being with an extinguished heart that hides in the shadows, shining so dimly that it is almost impossible to see. But despite failing in its ambition to become a star, brown dwarfs remain relentless beasts. And, unlike the true gods of light, they are cold enough for there to be a kind of climate within them. With their huge densities slightly larger than Jupiter but up to 75 times more massive than it, megastorms on brown dwarfs take on a whole new meaning. The unique conditions of their atmospheres give rise to tremendous winds that conceal the ashes of a heart that never beat. Surface temperatures do not exceed 2,000 degrees, but descending into that abyss, we approach the core of what was almost a star. The extreme temperatures and pressures on the way to their depths cause iron itself to evaporate and rise to the surface, trying to escape from the depths of the monster. At that moment, it solidifies again, becoming a fine sand that creates a canvas in the sky. Scorching iron clouds that rain metal back toward the heart. A rain in which the iron, dragged by the fierce gravity of the brown dwarf, plunges into its depths at hundreds of kilometers per hour. A storm in the sky of a failed star hidden in the shadows of space and time. The search for the wrath of the winds had transported us to the limits of that eternal ocean of darkness that we inhabit. To the claws of the monsters that lurk from the shadows and remind us of the insensitivity of nature. A cosmos indifferent to all suffering that creates landscapes where hostility reigns. And that we, from the remoteness, will continue to explore, immersing ourselves in the wrath of this cruel and wonderful universe.